So now I'm going to show you how to use the digital multimeter. So that's this guy over here. So now I'll just show you. When we first turn it on, it's going to boot up and it comes up as in voltmeter mode, okay? And when we want to measure volts, you see there's this V here, okay? So we put the lead in the top red socket, and then we put the black one in the black one just below, okay? That's the same configuration as we use when we are using it as an ohm meter. But right now it's a voltmeter. Let's make our measurement. So now this is a de-energized circuit. It's turned off, so the power supplies are turned off. And this is the circuit that we used before when we were looking at the breadboard. So we've got plus 15 volts coming through here, and then going through 4 series resistors of each 1 kilo ohm, okay? And so then we have the leads of the voltmeter connected to these banana jacks, and then these 8 hole headers are connected to each socket. So then this is our positive side of our voltmeter, and this is our negative side of our voltmeter. So we're essentially measuring the supply voltage across here. So let's turn on the power and see what we're going to measure, okay? Turning on the power, and then we are measuring 14.9 volts. So that's basically 15 volts. This is not an ideal supply here, this 15 volts, so it's 14.9 volts, which is fine. So now let's say we wanted to measure the voltage across this resistor. Okay, well, let's figure out what should it be. Okay, so using the voltage divider, it's going to be 15 volts times 1 kilo ohm, all divided by 4 kilo ohms. Okay, so then that works out to, so that's 15 times 1 divided by 4, and that works out to 3.75. Okay, so then let's make the measurement and confirm. So we should be seeing 3.75 volts here. Okay, so now let's look at the voltmeter. Okay, so it's bang on, 3.75 volts. Okay, so that's what we expect. The voltmeter appears to the circuit itself as an infinite impedance, so, or infinite resistance, so there's no current flowing through these leads, okay? So it doesn't interrupt the circuit in any way, and it doesn't diminish the voltage, because if there was current flowing through here, there would be a smaller voltage drop across that resistor. So now let's go into the ammeter mode. So let's measure the resistance of those 4 resistors. So I've turned off the power, right? We can't have a powered on circuit when you're measuring resistance. So let's go in here and see there's this ohm symbol here. So we got to have one lead on the top one for the resistance measurement, and this black one in the one below it, okay? So it's in the right configuration. So now these are 4 series resistors, and it should be 4 kilo ohms, okay? So let's see what it's measuring. Oh, and then we have to put it in the ohm meter mode, so that's this ohm symbol here. So we push this one. Now it's in kilo ohms. Oh, but look, it's 0.7 kilo ohms, and we know that's wrong because we're expecting 4 kilo ohms. Okay, so I know what the problem is, and the problem is, even though I've de-energized the circuit, the power supply is still connected, so it's off, but it's interfering with my measurement. So I'm going to completely isolate this circuit. Okay, so now it's just the resistors being measured by the ohm meter. Okay, so it should be 4 kilo ohms. So let's go back to our measurement. Okay, 3.95 kilo ohms. So that's right. Okay, so that's the important thing with measuring resistance. You have to measure the resistance directly without it being part of any other part of the circuit, and even if it's connected to a power supply that's turned off. Okay, so then that was the resistance measurement, okay? And then, so now let's make a measurement of the current. So what's the current going to be flowing through here, okay? So it's 15 volts divided by 4 ohms, so that should be what, 3.75 milliamps? Is that right? Okay, So now the trick with the ammeter must make a measurement in series with the circuit, okay? So that means we have to break this circuit and put the ammeter in series. So I'm just going to arbitrarily put the ammeter in series with this middle node, okay? So I've broken the circuit, okay? And I'm going to put the positive on this side of the circuit, and I'm going to put the negative over here. So now what's going to happen? So we're going to have current flowing out of the positive 15 volts, coming around into the circuit, go through this first resistor, which is connected to the second resistor. So the current's going to flow. It's going to flow to the ammeter through this wire, go all the way through the ammeter. The ammeter is going to look like a short circuit. Okay? It's not going to interfere with the current. The current's going to come back through the negative of the ammeter, back into the circuit, and continue along the path. Okay? And then the return path back to the common. So that's a closed circuit, and the ammeter is in series with the branch who I'm measuring. Okay, so now we have to make some changes to the meter. So we have to put it in the ohms mode. So you see DCI, that's for current measurements. DCV is for voltage measurement. So this is highlighted in blue. It's a special function. We have to hit shift, okay, and then hit for the DCI, and see, it becomes milliamps DC. So it's DC current. Now there's another thing here. See this I? That means you have to use this socket for the current measurement. So we've got to take this red guy out, put it in here. Common can stay here, okay? So now we can make a current measurement. So once I turn it on, we'll see the lights come on, and my prediction is going to be something like 3.75 milliamps. And let's see what it's measuring. Okay, look, 3.769 milliamps, okay? So that's what I'm expecting. So that's a current measurement. So that's the basics of how to use this meter. Read your lab handout carefully and listen to your professor talk about how meters work, and be careful when you're making measurements, especially with the ammeter, because it's very easy to blow it, because it's like putting a short circuit into the circuit. So if we had our original circuit like this, let's say, so that's the original circuit, and let's say I wanted to find out the current. I'm going to turn it off so I don't want to blow anything. But let's say I wanted to measure the current, and I thought, oh, I'll just measure it all the way across here, just like voltage. Well, what would happen is the current would flow from this plus 15, go through here, go through the ammeter, go through a short circuit, because the ammeter looks like a short circuit, and then the current would flow back here and back to the common. So it would be as if I put a short circuit directly across the 15 volt supply like that. And that's bad. We'd melt the wire or blow up the power supply. Okay? So that's what would happen if you were to make a current measurement like that. So you have to be really careful. You have to break the circuit that you're measuring and put the ammeter in series. Okay? So you can't do something like measure the current across here by going like this. Again, what that'll do is that'll short out that resistor, for example, and you'll get only the current that would flow through a circuit with 3 1 kilo ohm resistors. So you get like 5 milliamps, right? Because this one would be shorted out. No current would flow through here. All the current would flow through the ammeter. Anyway, so keep that in mind. Keep in mind when you're making a resistance measurement, you measure just that resistor directly outside of the circuit. And I think that's it. You're going to get lots of practice in the lab using these instruments.